read question number 5. Next is 8.2. Okay, in a parallelogram A, B, C, D, E and F are the midpoints of side A, B and C, D respectively. So that line segment AF and EC trisect the diagonal BD. Okay, so we have to prove that this BD is this DB, this or BD or DB is split into three equal parts. Okay, DP, PQ and QB should be equal. Trisect means nothing but three equal parts. Okay, now let us go for the solution. Okay, so we know this half of AB is equal to half of DC. Okay, so here it is this is a midpoint. Okay, here it is F is the midpoint. So okay, this half of AB, this line half of AB is equal to half of DC. Okay, so this is a midpoint, this is a midpoint, so we can say that because AB is a parallel to DC, they have given it is a parallelogram. They are, in the question it is given parallelogram, so AB is a parallel to DC, and you know in parallelogram we know that both are opposites are equal. Now we can say that AE, so based on that we can say that AE is equal to FC. Okay, AE is equal to FC because this is off actually. Okay, this is off, this is off. Okay, so we can say that AE is equal to FC because this is off portion, this is a off portion. So now we can say that parallelogram, now this part AECF, we can say the parallelogram, okay, AECF. So AECF is a parallelogram. Okay, to prove this AEFC is a parallelogram, so we have taken this. Now this side, this AE is equal to FC and also parallel. So naturally this AECF is a parallelogram. Okay, now first one is over. Now let us go for second thing. Okay, now why we have proved this parallelogram, so we will know in the subsequent steps. Okay, now let us take this triangle ABQ. Triangle ABP. Okay, ABP. So we already know it is the midpoint. Okay, already know it's the midpoint. Let us go for the midpoint theorem. The midpoint theorem says a line, okay, through the midpoint of a side of a triangle parallel to another side bisect the third side. Now we can come to the sum. A line through the midpoint of a side of a triangle. So here the E is the midpoint. This side AB parallel to another side, it is parallel to this AF, parallel to another side, bisect the third side. This is the third side, PQ is this PB is the third side, so it bisect. Okay, Q is the midpoint, Q is the midpoint of this PB. Okay, so as per theorem this Q is the midpoint of PB because it bisect. As per theorem this line bisect this Q. So naturally what happens, we can say Q is the midpoint of PB. Okay, so naturally what happens, PQ is equal to QB. Let us take this as equation number 1. Okay, because it is a midpoint means PQ is equal to QB. Okay, so we have proved one thing. So this is equation number 1. Let us go for triangle, second triangle. In triangle CDQ, let us take CDQ. The same theorem, the same midpoint theorem we are going to apply. Okay, now this F is the midpoint, it is already given. F is the midpoint and a line is drawn here. Okay, a line is drawn here and this line is parallel to CQ. Okay, this line is parallel to CQ, so naturally it bisect the third side. So P is the midpoint of PQ. So as per midpoint theorem, okay, so P is the midpoint of dq. Okay, cdq. So we have proved that p is the midpoint of a dq. So what happens naturally? What happens? PD. Okay, PD is equal to PQ. This is equation number 2. Okay, this is equation number 2. Now what happens? So let us combine this both the things. Okay, PQ equal to QB and PQ equal to PD. Okay, this is equation number 1. This is equation number 2. Now we can say that PQ is equal to QB and QB is equal to PD. So PQ, okay, this PQ, QB and DP or PD both are equal. Both are equal means both are equal. All are equal. So it only means it only means that it only means that DB is trisected. DB is trisected by okay, we can write DB is trisected. Okay, so this DB and PQ and QB are equal. It only means that it is a trisected means all the three parts are equal. Okay, this is a very simple sum. Okay, thank you.